Welcome to this session on finding new paths in design research. My name is Susanne Nilsson, and I will be the chair for this 1 hour, a bit more than 1 hour here, where we will have a discussion and presentation. And I think we have some very interesting presentations to look forward to, and where all the researchers using different means are offering us new insights into how design research can and need to be changed and developed. And not the least due to the introduction of advanced digital technologies and products, which are increasing the connectivity and complexity. As we also saw, you who were part of the Danica Kragic's presentation just recently on AI, machine learning, and robotics. And I think that is really well reflected in her speech there. So this will be a really nice session, I believe. And I think that Marco, you have a presentation of all. Yeah, we can see all the authors here, right? And I hope you all. Yeah,
on the presenters here, but you can see the authors.
Perfect. Here. All the presenters are here, and we have 5 papers that will be presented. We have Mariana Oliveira, who is currently pursuing her PhD degree in production engineering at the Polytechnic School of the University of São Paulo in Brazil. And her research interests involve the application of design thinking in complex settings, especially healthcare organizations and projects. And she will present her paper on a new construct of design thinking. And then we also have Aleksandra Sviridova, who has an industrial experience in the field of digital design, 3D printing, and prototyping. And her particular interest is in the overlap between the arts and technology. And she's currently pursuing her PhD at the Antwerp Design Factory at the University of Antwerp. And she will tell us of how to use demonstrators as sources of tacit knowledge and a mean to access the inaccessible. And then we have another paper by Mark Goudswaard, who is a research associate in Design and Manufacturing Futures Lab at the University of Bristol. And his research includes design for additive manufacturing, integration of physical and digital prototyping methods, coordination of distributed manufacturing resources, and design neurocognition. And he will present how hackathons can be used for design research by sharing learnings from an international design engineering challenge from last year. And then we have a 4th paper by Marco Rosso, who currently works as a mechanical designer at Chris Bangle and Associates, a design consultant agency. And as a researcher, engineer, and design strategy expert, he has gained experience in robotics, industrial design, and automotive and architecture. And he will discuss a new design method for these connected and smart products, which he refers to as objectomy. And then finally, we have a paper by David Mesa, who is a product design engineer at Swinburne University of Technology in Australia, analyzing practices to improve university technology development and commercialization. And his research explores the process of identifying applications for new scientific discoveries and transforming those ideas into products that can reach the market. And he will present exactly something related to this, a case study of how to explore the role of design in maturing university-developed technologies. So I think we have a really nice session. Looking forward to taking part of your presentations, and also I encourage you all, while listening to the presentations, you can provide your reflections and comments in the chat. And don't be shy away from doing that, because that will really create a more lively discussion, and that is very nice, both for the presenters and for all of us, that we have different ways and views on the presentations. Please, though, try to mark whether your comment or questions relates to presentation 1, 2, 3, etc. So it's clear when we start a discussion what presentation you're referring your reflection or comment to. Any questions before we start? Nope.
Just quick. Very quick. Are we doing questions all at the end, or are we going to do them after each presentation?
Yeah, we're doing the questions by the end. That's my plan. Yeah, exactly. So let's listen to all the presentations, because my view, at least, is that we can see similarities and things that can be discussed between them. At least I've seen it. So let us all listen to the presentation, and then we start the questions. Great, thank you for asking, Mark. Okay, and I ask Marco here to start the presentation. Thank you.
Hello, I am Mariana Oliveira. I'm a PhD candidate at the Department of Production Engineering of the University of São Paulo, and today I'll be presenting the paper entitled Unveiling the Construct of Design Thinking, an Exploratory Study. The paper is co-authored by me and Professor Eduardo Zancul. The presentation will begin with a short introduction about the theme of the paper, followed by a glance on the theoretical background of the field. Then, we will move on to present our study design and discuss the results we came to achieve in this paper. Finally, we will present a conclusive summary of our study and recommendations for future research. Well, design thinking is a widely known and adopted approach amongst management practitioners. It has been extensively adopted in managerial practice, but it has not been as thoroughly analyzed in academia. This scenario has made design thinking-related academic efforts grow disconnected and resulted in the term design thinking lacking a clear-cut, unique definition. The variety of definitions attributed to design thinking puts it at the risk of becoming an umbrella construct, with a loose meaning that might delay or even collapse theory development. This work aims to contribute to the theory by providing a comprehensive construct of design thinking and mitigating these inconsistencies. Design thinking is a context-dependent approach and may be portrayed as a process, a method, a mental approach, a culture, or a mix thereof. Hence, it is intrinsically ambiguous, and any attempt on providing it with a single construct must take that into consideration. Design thinking is inspired by the design practice and is composed of attributes such as creativity, innovation, user-centeredness, iteration, experimentation, interdisciplinary collaboration, tolerance to ambiguity, and failure. More recently, a capability lens has been employed in design thinking studies, and they have proposed that design thinking gathers a set of teachable practices that enable the development of dynamic innovation skills, meaning that design thinking can be thought of as a social technology. Hence, the value of design thinking also lies on empowering individuals into becoming owners of a shared innovation process. Based on a literature review of design thinking research, we will establish a construct composed of a comprehensive formal definition and a set of associated properties. As for the literature review, in the identification section, we began our search in Scopus database using the string DesignThink. We separated our finds in two clusters, which were works published up to 2018 and works published from 2019 onwards. Then, we selected the 100 most cited papers in each cluster for title and abstract review in the screening section. There, we were looking for papers that contributed to design thinking theory or to connecting design thinking with other management theories. After title and abstract review, we selected 31 papers to go into our eligibility section, where we performed a full text review. Finally, we considered 21 papers in our studies. After the review, we put together the following formal definition for our construct. Design thinking is an abductive, human-centered approach for problem solving. I will now decouple the definition into its properties. First, design thinking is founded in abductive reasoning. In other words, when employing design thinking, the individual must face the problem in an abductive view, focusing on understanding what is the desired value expected from solving this problem, and then moving backwards to define the mechanism by which the value will be delivered. And hence, the individual will be open to multiple solution paths, to iteration when building the solution, and will embrace the ambiguities of their inquiry. Human-centeredness in design thinking is twofold. First, design thinking is rooted in holistically understanding the complexities of human behavior and desirability through empathy. Secondly, it holds a luddic character for individuals involved in the design thinking initiative, which fosters the development of a psychologically safe and stimulating environment for multidisciplinary co-creation. Moving forward, we present design thinking as an approach due to its multivalence. The label of design thinking has been put on structured step-by-step processes, toolboxes, ways of working, mental models, and so on. Our understanding is that, due to its social, technological, and infrastructuring character, its enactment might take place in different shapes depending on its environment. Finally, we employ this abductive, human-centered approach seeking to solve one or more problems. Design thinking adoption can steer problem-solving either by gathering knowledgeable individuals who can contribute for intentionally addressing a known problem in a sequence of preconceived activities, for example, or by empowering individuals to apply a human-centered and abductive lens into emerging problems, and hence enable them to continuously solve problems with creative confidence. Summing up, the properties that compose our proposed construct portray more tangible expressions of design thinking, which can help us to advance empirical studies and adopt other methodologies in design thinking research that are not employed currently. This was our first exploratory study on this topic, and it surely has its limitations. Future studies could rely on other databases. They could employ speech analysis techniques to build a more robust foundation for the construct, as well as they could complement and validate the construct with practitioners and researchers on design thinking. Thank you for your attention, and feel free to contact me or Eduardo if you have any contributions and questions for us.
Hello, my name is Aleksandra Sviridova, and today I want to present you our paper that we made together with my colleagues from the University of Antwerp, Drim, Stokhuijzen, and Jouke, Verlinden. Let me walk you through this. Industrial design has evolved throughout its history from the era of objects designed by individuals to complex intangible systems developed by multidisciplinary groups. The aim of design has also shifted from economic factors to social and ecological values. Design is about practice, but this practice rests on theoretical foundations. Design takes great inspiration from other domains, constantly expanding into new territories, bringing and incorporating new ideas and concepts. But it occurs so rapidly and sometimes chaotic that the foundations cannot keep up and leave the practice without support. Scientific approach assumes that the researchers keep the distance from the studied system, remaining a non-involved observer. Although scientific tools are powerful, when the research aims to investigate the foundation of design practice, the tools have seemed to reach their limits of applicability due to and their use often leads to ungeneralizable situated knowledge. Whilst in design, we're very interested to get inside the design system to reach the most comprehensive understanding of the studied subject. Design is about finding a simple solution for the user, even though the design process might be very complex beyond the facade. Just like a routinely ordinary process of opening a door with a key becomes impossibly complex when we consider all the physics behind it or try to program a robot to do it. A versatile concept called demonstrators, combining design, art, and engineering, represent design objects, can solve even very abstract problems. Studying them could be a way to handle the increasing complexity of design challenges. Let me give you some examples so that you better understand what demonstrators are. Mincaphone is a giant tumbleweed-like structure designed to roll across the deserts of Afghanistan and mine them. Although its design was never efficient to do so, it drew big attention in the press and allowed the designers to raise enough money for the drone project that is supposed to do the same but efficiently. A company that was designed 3D printed bridge, MX3D, wanted to test the durability of metal joints and they decided to make a bike with a similar structure. It allowed them to perform the test, but also promote their technology to policymakers to make it less alien-like. By the way, you might have seen the 3D printed bridge in Amsterdam, like the result. Finally, a 3D printed dress was presented on a catwalk in 2018. This technology unlocked the entire new world of forms and materials and bring it closer to general public. In the video, you can see the process of making it and the spectacular result. In short, demonstrators are design projects that are made to be exhibited. They convey a message and they use innovative yet available technologies. Demonstrators can be a solution to very abstract problems, like the one that the authors of this paper were involved in the creation of. Flanders Make, a research center for the manufacturing industry, developed a new algorithm of optimization, and they wanted to explain and promote it to their clients. Thus, the main challenge for the designers was to explain such an abstract thing to people far from mathematics and computer science. The result was a stand of two parts: a physical relief depicting a famous Belgian racetrack and a cabinet hiding the projector. The animation explaining the process was pre-recorded and mapped on the surface. The idea was to present a new and an old algorithm as cars whose components are adjusted according to these different algorithms' goals. The race shows the advantages of using each of them depending on weather conditions. All this you can see right now, like the animation exactly, you can see right now in the screen. As you can see, the result looks pretty simple for such a challenge. Yet the project is more than complex on a closer look. A metaphorical embodiment of a comparison between two algorithms is what designers used to initiate a complex communication process between stakeholders, despite its look as a stand with a relief and projected animation on it. The process can be researched further, as well as other potential directions, and none of them was foreseen in advance, before or during the design process. They were discovered upon looking back at the finished project while asking questions such as what had happened, how do we analyze and explore deeper? And this is what the inaccessible research is. Here I'd like to introduce Rudstrom's concept of a fluid definition. He claims that due to the dichotomy between the particular and the general inherent to design space, it should be seen as a spectrum ranging from what a design is to what designing is, and how the space should be populated with notions. The components of it cannot and should not be precisely defined from an analytical point of view, as they lose the inherent instability that we really need in design to make it creative. Although, when the research focus is narrowed down and becomes discrete, then more stable definitions would be useful. We argue that since demonstrators exist on different levels of abstractness, combine different mindsets, and represent different disciplines, they can be considered as such fluid definitions and hence embody all the spectrums at once. When the space is discrete, like if we focus on a communication aspect like in our example, the narrow research question will cut off all excess. Such approach is natural for designers due to their developed skills in intuition and empathy that allow them to literally put themselves into other people's shoes and observe from different perspectives while being inside. In our paper, we suggest a few tools that might be adopted from other disciplines and help us develop our own. Please have a look to it to get inspired. Meanwhile, the questions of development of such tools and their application in business and education will be explored in our future work. Thank you for your attention.
Hello, and welcome to this presentation on the paper entitled Virtually Hosted Hackathons for Design Research, Lessons Learned from the International Design Engineering or IDEA Challenge 2021. My name is Mark Goudswaard. I'm from the University of Bristol, and I'm going to be taking you through this paper today on behalf of my co-authors listed below. The IDEA Challenge is a virtually hosted design hackathon which was inaugurated in 2021. And whilst hackathons have been around for around 20 years, these are an emerging area in design research. This is because they provide some unique opportunities for research in the design process. This includes that they cover early stages of design, there are significant time pressures in designing, and there are different and distinct levels of design expertise in different participants. Given this, the idea challenge was devised to investigate the potential of such scenarios for capturing design research datasets, to understand the design activity within these virtually hosted hackathons, and also to foster community between design research groups. The IDEA 2021 challenge was to develop a low-cost vaccine storage unit that could facilitate vaccine distribution in hard-to-reach areas of Colombia. The hackathon itself ran for 4 days, and teams were required to generate a physical prototype that could be physically tested, validated, and then this would be combined with digital prototypes such as CAD models, which would constitute their final design submission. The designs themselves were evaluated by pitches to a panel of industrialists and academics, as well as the physical performance of their prototypes. The tool used to capture prototypes for the design study carried out was Protobooth, which is an online platform that captures the who, what, how, when, and why of prototyping. And more details about Protobooth are included in a separate paper, which will be presented by colleague Lorenzo Giunta on Wednesday. The study and the hackathon itself were reviewed by undertaking surveys and workshops with participants to garner their feedback. In 4 days, the 4 teams, featuring 14 designers, generated a dataset with over 200 prototypes. These nodes were all connected by almost 400 edges in terms of who made each prototype, and almost 1,000 edges in terms of which prototypes influenced each other. As real vaccines couldn't be used in the challenge, an egg was used as a proxy, and the types of prototypes that were captured by Protobooth during the IDEA challenge included physical prototypes, as well as CAD models and sketches. Evaluation videos were also captured to demonstrate prototype performance, and I can report that participants needed no encouragement to capture slow motion videos of drop tests or to demonstrate novel features such as emergency aerosol cooling systems. Unfortunately, eggs were harmed in the making of these videos and many others captured by Protobooth. Protobooth captures projects, users, prototypes, and the respective influences and relationships. And this enables 3 main outputs. The first of these is a log of prototyping history, and this essentially enables the definition of why a product is the way it is, and importantly, why it is not another way. This information can then be synthesized into various network visualizations, and this is the topic of a separate paper, which will be presented by colleague Lee Kent in Thursday's session D224, 2:30 p.m. Recommend going along if network visualizations are interesting to you. The data can also be used to provide analysis and insights into prototyping practices used in design hackathons, in particular with respect to how different methods and domains are used. And this figure here shows how Team D transitioned between physical and digital domains during the course of the hackathon. From the surveys and workshop hosted after the challenge, we can reflect on what went well and what could be improved on. Participants found the challenge appropriate and they liked the structure of the event. They also commented on liking the escape from the day-to-day and being able to work collaboratively with colleagues. A couple of quotes from respondents were that the topic was interesting and really fun to have a challenge where we had to apply things that we teach in research, and it was interesting to compare our skills with other labs from Europe. A few points were highlighted for how it could be improved. These included social events, which would enable more opportunities to interact with other teams, and perhaps future IDEA challenges having a more closed design task with prescriptive outputs. And we've since been able to take the comments and feedback from the first idea challenge into Idea 2022, which was hosted by NTNU in April, so a few weeks ago. The challenge for this one was the development of low-cost portable hydropower, and developments which were taken on board where additional teams took part. We also included the Great Ideas Exchange, where we paired up researchers with similar areas such that they could interact and discuss their areas of research. And we also included daily Taskmaster challenges. The study used this time was twofold and used the new and improved Protobooth to capture prototyping practice, and also used trackers to understand designers' use of makerspaces using spatial location. In terms of further work for the Idea Challenge, we'd like to continue to build Idea as a research platform that can also foster community within engineering design. We want to create an environment for PhD students or early career researchers to run or contribute to design studies. In doing this, we'd like to increase participating institutions. And as a question that I could pose to those of you here in this session, would you like to run Idea 2023 as a design study? If so, please get in touch. We would like to explore in the future also hosting the challenge in person to improve networking. And we still have further analysis to conduct on the datasets from Idea 2021 and 2022. The core focus of this is what is the purposes and affordances of different prototyping domains and media. So with that, I will close and say thank you very much for listening, and I look forward to any questions or comments in the forthcoming discussion session.
Hello, good morning everybody. I am Marco Rosso and I'm here to present a paper, Design Method Review for Smart Product, Objectomy, a New Design Approach. It was made possible thanks to the collaboration of Chris Bengal and I from Chris Bengal Associate and Francesca Montagna and Marco Cantamessa from the Department of Management and Production Engineering of Politecnico di Torino. Starting from the context, digital technologies and digitalization have a strong consequence on the designer, both as individual level or at team member level, as well as on the design process that lead to the creation of a new artifact. Through this paper, we aim at analyzing the design process, focusing on the design variable, design method involved in the design of digital and smart product. We created a conceptual framework in order to highlight the limitation of current design method and identify the seeds for future research. The same framework is used to analyze a new design method called Objectomy and his application, asking ourselves, first, what kind of aid does such method really provide? Second, what are, if there are any, additional variables that smart product activate which cannot be covered by traditional method that instead Objectomy is able to manage. From a methodological point of view, the research has been carried out through a qualitative approach. The first part of this paper has been dedicated to the literature review, aimed at identifying the state of art of the design method and their classification. The second part is dedicated at creating a conceptual framework, and the rest of the effort has been focused on formalizing the method Objectomy and analyzing its application. Since there is still not a common consensus on the definition of smart product, we analyze different contributions from different authors, relevant authors, about how to define a smart product. And we come out with a 4 cluster of capabilities that led to the definition of smart product for the scope of this paper. Smart products are physical objects with enhanced digital capabilities which can collect and elaborate data, can interact with other objects, human and with the environment, as well as possess an identity and being able to participate in decision-making processes. Many models of design process exist in the literature: stage-based versus activity-based model, solution-oriented versus problem-oriented, abstract versus procedural versus analytical approaches. In spite of that, literature agreed that the design process is a sequence of defined activities, sometimes repeated, in particular according to Poland-based design task clarification, concept generation, and concept selection. The literature agree also on the concept of design variable that can be defined as a set of semantic elements that are domain independent, that are represented by a common criteria that designer adopts to make progress in the execution of his or her design task. The most common design variables are function, behavior, structure, affordance, and architecture. Objectomy, instead, is a design approach that has its origin in the car design industry from the Chris Bengal design philosophy, specifically in the emotionally charged aesthetic of a car, but it has been applied in many different industries, from the automotive to the consumer good to the robotics and automation sector. According to Chris Bengal, objectomy enables the designer to create a mindset that allows him or her to put him or herself in the shoes of the object. In other words, giving a character to the object itself. The word object is really important and represents an abstraction of a product, service, or a system, and the object takes the role of an agent that acts in the environment. From the design practice point of view, objectomy can be resumed in three-stage process. First, meta-analysis is a deep exploration of the design process problem, mainly on a semantic level, with the aim of defining its boundaries and the list of agents involved. Second, the interaction simulation, by which each participant of the design process must identify themselves with the various agents by, for example, role-playing, simulation, or other technique. Third, character definition is the analysis of the previous outcome in order to derive the event and the attitude of various agents and create the event-attitude matrix. So here, in order to understand how objectomy works, we provide a case study, the kitchen of the future. The main challenge was creating a new user experience in the kitchen environment through innovative product and service. The application of objectomy approach allowed the designer to detach his mind from the technical functionalism and to see unexpected feature and not obvious aspect of the design research. At this point, in order to formalize the potentiality of such approach, we decided to analyze and compare objectomy with other design methods by the conceptual framework. The framework has been designed as the design method on the row and design variable on the column, and each cell represents the relationship between the two, if there are any. This has been done because, first, it explicates the interaction within the socio-technical system. Second, it explored all possible declination of affordance in the interaction and also the ones activated by the object behavior itself. In conclusion, we can say that the concept framework can be used as a design research tool. There is a lack of design methods specifically created for smart and digital product, and the current methods are reductive in supporting the designer task. Even there are some methods, software-oriented, that help the designer, but they don't consider the physicality of the smart product. Objectomy assumes that the object is a living creature. In other words, the object is not static, but dynamic, with an evolution coherent with its purpose. For this reason, objectomy allows to explore all the design variables and the conceptual phase, and to be a support in the concept generation. Of course, this paper can be considered as a starting point for future research on both the framework and objectomy approach. Thank you for the attention.
Hello, everyone. My name is David Mesa. I will be talking about the relationship between design and science in commercializing research and how design can help mature university develop technology. We're going to go through an introduction, then I'm going to talk about the methodology we used, the research results, and the research significance. So the paper we presented is one snapshot of the research we're going to talk about. So first, we need to understand what the value of that means. The value of that of research commercialization is that place where a lot of technologies and scientific research projects perish. So there's a big gap between university research and the market, and some countries like Australia with really good scientific research and publication output are not very good at commercializing research. What happens is that then that money is not reflected in the impact it generates on nations' economies. So we proposed integrating design early in scientific development and exploration and in the development of technologies. So we can see this graph here where we show the different maturation levels of technology. And here we show the value of that is starting at technology readiness level. This is where technologies need to be proven outside the lab in a market-directed platform. And this is where most scientists struggle. So this is where design can really also play a very important role and help bridging that gap. Of course, there are other disciplines that need to be involved, but we're going to focus on design and science. So some of the critical issues we found in commercializing research, after interviewing scientists and analyzing their approaches and the literature, were that there's really poor communication with industry, there is a very low understanding of industry needs, and there is really poor market research in technology development or no market research at all. So this graph, it's read from the bottom to the top, being the problems in the bottom, the ones that affect the most. So then we proposed different solutions to tackle those issues. And we found that perhaps integration of the product development process early could help improve some of those. Then also we needed to define a commercialization strategy early, and there needed to be high quality technology demonstrators. This is the framework we used, the DRM, for doing the research. This is the methodology. So we did some observation and interviews to understand the issues. Then we proposed a framework, and that framework was tested with a practice-based approach. And we used the survey to evaluate the impact of that framework. So we're going to focus on the survey and the practice-based design research. This is the framework we proposed. From the planning stage onwards, it's the traditional product development process from Eppinger and Ulrich. And on the left, we can see the different phases of technology maturation. So this is how each stage should be integrated in different phases depending on how mature the technologies are. And we added these two different strategy definition of market selection stages that were tested in one technology but not in the other one. So the first technology we collaborated with scientists in was a graphene-based supercapacitor technology for storing energy, and the second one, graphene seawater desalinating technology. So that one followed a more traditional product development approach where the scientists had an idea and the designers helped develop that solution. In the first one, there was some different activities, very detailed, as you saw in the previous one, where we actually went through analyzing different markets, analyzing market trends, proposing future scenarios, doing workshops to identify opportunities for those scenarios, and proposing opportunity maps, and using technology road mapping to actually be able to understand what would be the best route to market for that particular technology. Both projects were designed through a traditional design approach. We did planning, sketching, 3D modeling, then we produced prototypes and we tested them. And the projects were exhibited in a conference. So that conference was the International Conference of Nanomaterial and Nanomaterial Science and Applications. And it was a good opportunity to compare or measure the impact of the framework because we had 5 different projects. One was a fully intervened project between designers and scientists. The second was the partially intervened project with the designer and scientist. And then the other 2 projects were developed only by scientists and they didn't follow the framework. So it was a good opportunity because they shared the same budget and had a similar timeframe for development. That's what we used to analyze the framework was a survey. Basically, we collected information about conference participants about the scientific principle, the social and environmental relevance of the technologies, the commercial relevance, and the technology readiness level. So we collected 23 valid surveys comparing the technologies, and the participants took around 20 minutes visiting the 5 exhibitions. That's why we couldn't also collect more responses. They had to rank the technologies from 1 to 5, being 5 the best answer, and they had also the option to say that they could not perceive the questions asked with this box. So that box was considered then as a 0 in the value. And if we analyze the frequency of do not know answers per project, we can see that the supercapacitor project or the full intervention was very well understood by the participants. Then the partially intervened project had some do not know answers, 7 of them. But then the 3 non-intervened projects had a lot of do not know answers, which means participants couldn't understand some of the principles in them. If we look in detail at the results, the demonstration of the scientific principle had a very high result in the fully intervened project, then a bit poorly in the partially intervened projects, and then the 3 other non-intervened projects had really poor results. Same occurred with the social relevance. Actually, the fully intervened and the partially intervened projects both scored very well. Then the 3 other projects didn't score well at all. Demonstrating the commercial relevance, of course, super important for commercializing research. The fully intervened project had very high results, while the partially intervened was second. And the same occurred with the technology readiness levels. So we can see a pattern here. The framework definitely was important, but the strategy definition and market selection stages really important, impacted how people perceive the value of the technology. So designers shouldn't play a role only in showing how prototypes work, but also in determining what are the opportunities that should be followed with the scientific research and developing the technology. So this is very significant because we developed and detailed activities that should be followed or could be followed in order to mature technology, and we propose a way to do it by combining design and science. So designers can also help guiding scientific exploration by determining the directions with the scientists where technologies should go.
Excellent. Thank you, all presenters. That was a really nice summary of your papers. So I suggest here, we have a number of questions coming up in the chat. So my suggestion is actually that we start with those questions and we start with presentation 1 and we go through to see. So we kind of discuss each paper before we also try to discuss the connections here between kind of a lot of the papers in this session. So we have for paper 1 here from James, the interesting work. I have always thought design thinking as the study of how we think when we design. But is this a case where we use the same term for an approach as well as the study of? Mariana, would you like to comment?
Sure. Thank you. Can you hear me?
Yes, we hear you.
Thank you for your question, James. Actually, we cut this from the presentation that is written on the paper. We actually adopt Yola Johansson's perspective on this. She has a paper from 2013 where she differs design thinking from designerly thinking, where design thinking is a practice that was adopted by the managerial practice on employing a way in how designers think and work, decoupling from design practice into management, and designerly thinking studies the actual ways professional designers and conduct their practices. So we strictly follow the managerial concept design thinking and not designerly thinking, which goes back to the 60s.
Thank you, Mariana. And you also put up the link here, so and James is thanking you as well here. Great. And we also have from Lucienne Blessing, who is she noticed that the search keyword you used was design think, and she highlights that the vast amount of literature on design does not use the term design thinking. And what was your reason to use only that term?
Surely. Thank you for your question. Wow. As I said, our interest is in the managerial concept of design thinking. And well, and this concept is fuzzy in its core. That's why we're doing a research on it. And since it's the first exploratory study, we decided to select only papers that exclusively claim to employ design thinking. But surely for a full study, we would have to reanalyze the search strings, and I was actually looking for your suggestion on literature for us. Thank you.
Thank you, Mariana. And Lucienne, would you like to comment or add something? Great. Any more questions on paper 1?
I think Aleksandra.
Yes.
Question.
Aleksandra. Yes, there we go. Do you think the design thinking and designerly thinking are the same in the beginning and then differentiate according to the way where they have been applied? Is that your?
Well, I think that I personally believe that design thinking will never be as deep as designerly thinking, because designerly thinking stems from specialization in the actual design practice, and design thinking as a managerial construct proposes to be a design which can be virtually employed by anyone, even if they don't specialize in design knowledge in that. So I think you could say that design thinking stems from designerly thinking, but we actually have a paper in design studies by Filip, which was just hosting another session in the last hour, where he puts this design research and its boundaries with cognitive research, managerial research, user and organization levels, concrete and abstract level. And you see that design thinking is at the intersection of the organizational level and organizational level and manager in how do I say it? And the cognitive design tools and methods. So I think design thinking is just a small part of designerly thinking.
Mm-hmm. Are you happy with that, Aleksandra? Yeah. And thank you. Yeah. And Lucienne, thanks, Mariana. I still would do a more detailed study involving the research that focus on design thinking concepts and processes, but was never called that way. And I noticed that many now call everything that was called design thinking, and this may be why the term looks fuzzy. Would you like to make a final point or reflection on that, Mariana?
Sure. Yeah, actually, I agree with that. And this study was actually motivated by, I'm currently pursuing my PhD, and we're trying to employ qualitative comparative analysis on to see the effectiveness of the use of design thinking in research groups. And we didn't have a solid construct to depart from to perform that qualitative comparative analysis. So we started this work to further advance that, to analyze what I think Luciana is referring to, what everyone called back then objective reasoning design and employing design practices and design thinking. And from this work, we're going to expand further into actually assessing whether employing design thinking in this way is effective or not.
So I think, great, thank you, excellent. Mariana, and maybe you and Lucienne may meet each other on the chat somewhere and could discuss this further. It's a really valuable comments here and questions. So I think we move to paper 2 in order to have time for all the papers. And we have one question in the chat, and it says, I wonder if you could elaborate on the difference between demonstrators and boundary or epistemic objects. Aleksandra, could you please comment?
This is very good question. Like whoever asked it really knew what they were asking about. So yeah, honestly, because this demonstrator term is kind of something also fuzzy, and boundary objects are also fuzzy. So in 2 words, I would say that not every boundary object is a demonstrator, but demonstrator is often can be considered as a boundary object. That's like in 2 words. So yeah, I have considered, and I think I mentioned it, but yeah, I would definitely go into studying or studying what boundary objects are used for more. So yeah, I would say I just covered this tiny little short understanding of what boundary objects can be. Yeah.
Mhm.
I hope I answered the question.
And Mark, would you like to comment or reflect?
Yeah, no, I think it's a good answer. I think it relates back to the, I suppose, exchange between Mariana and Lucienne about sort of things being called different things, and then over time people start researching, I don't know, boundary objects, then people start calling them demonstrators, then suddenly that's almost seems to be a different research area. But actually, it's the same thing, you're just calling it different names. So it's it's a good answer. Thank you.
Yeah. Can I say give a short remark? So yeah, exactly about this kind of interlapping terminology. Yeah, I was struggling to do a literature study exactly because of that. Because sometimes I read about prototypes and I understand they are talking about what I would call a demonstrator, and sometimes I read about boundary objects, and sometimes they're talking about something else. So yeah, it makes my work very difficult, yet exciting, I guess. Yeah, thank you.
Thank you, Mark and Aleksandra. Are there any other questions regarding Aleksandra's? Else, I have one. And because I think it's interesting, you're making use of demonstrators as a starting point to build new theories in design. And then you have selected, as an illustration, you select a certain demonstrator in your paper. Do you believe that this particular demonstrator have certain features that is more or less revealing or making it more or less easy to access the inaccessible, as you talk about as research as design? So, or will it change, or will different demonstrators, so to speak, characteristics, how will that affect, do you think, the building of your theories? How have you been thinking about that?
I think it's a good question, because this is one of the reason why I showed you examples, because I don't have a clear and a final definition for what a demonstrator is, and I think it's just not the right time to actually make it solid and concrete and reduce the possible space of its understanding. But what I mentioned is that each demonstrator is a final project. So it is basically a combination of designers or an artist or whatever you call the person, or a group of people, engineers working on this demonstrator, ideas, time-wise, what they want to put there, what they had access to. And I think it's very important that if, for example, we try to solve the same task, like with the first example, like to demine the deserts of Afghanistan, and if the same task would be, for example, would be addressed for me, like, hey, Sasha, design something for this, I would come up with a completely different idea, and the result would look completely different. So, and this also, I hope, makes a point that by the result of the work, in this case a demonstrator, you can already tell a lot about even maybe a person designing it, or maybe a problem that was put inside, or maybe cultural context, or maybe the time-wise that technologies that we had. I also hope that I answered your question.
So this is something that you will explore then in your studies here going forward?
I hope so.
Yeah. And also another question for you, because you're asking for methods, you call for methods to support this kind of theory building through demonstrators. And I was thinking, when you listen to the Marcus presentation of the objectomy.
Oh yes, of course. Maybe I wasn't able to formulate the question right now, but when I saw it, I was like, oh wow, this is exactly what I might be interested. So Marco, I will formulate my question and I will come back to you definitely.
Very good.
Okay.
Yeah, Marco, would you like to comment shortly? Or?
I think that I was preparing the answer for James in reality.
So let's go. So let's go to you. We start in order, order.
But definitely we can talk after that, Aleksandra. No problem. The thing is, my paper is basically divided in two parts. The first part is about the creation of a framework that works like a research tool for study design method. And the other part is instead trying to formalizing a new design method that is called objectomy. That is the method that we develop and we explore in the company that I worked for like 5 years. I hope that I answered to the James question.
Great. James. Yes, okay. Got it. Yeah. So good. So let's go to paper number 3 and go through the questions we have in the chat. We have I found at least one, I think. Maybe we didn't. Did I understand it right that this idea event is virtual, and is it important to keep it virtual? I guess assuming the methods that you're using. So please.
So it was virtual in part because I suppose we still are to an extent acting under some pandemic restrictions, so travel and sort of organizing events in person is difficult to do stuff sort of into the future. There's a tension here between because it's got dual aims. One of them is to do a design study and generate a prototyping data set that can give us insights into prototyping practices, and the other is to kind of build community and sort of allow sort of early career researchers to get together and meet other people at a similar sort of stage in their academic careers. So obviously networking is better in person. So if everybody would prefer to be working together in teams in person and sort of have that as an opportunity to get to know and get to meet people. However, hosting it virtually, so teams are sort of co-located working together, actually provided a really interesting window into carrying out a design study because all the teams were completely separated. So they didn't see what each other was up to. So you get sort of no bleed over of ideas and people take completely different approaches to their to the same design challenge. So it becomes a really interesting way to sort of get multiple teams undertaking the same design challenge but doing it separately. So there's no sort of bleed over or separation of or sort of what's the word, kind of, but yeah, bleeding of ideas. They don't share too much. So it could be, I suppose, to come back to the question, the idea event is virtual, and it has been virtual in its first 2 instantiations. And whether it's important to keep it virtual kind of depends what we want to do with it. I think it could, as a platform for studying prototyping, having it virtual is more valuable. But if we want to emphasize more the networking side and doing something in person, would be preferable.
You happy with that, Aleksandra?
Just maybe one tiny after question to answer. Yeah. So is it done in a way a designer or task or like a big service design task to how to organize this virtual event in a way?
Sorry, I didn't quite understand the question.
So is this idea event then can be considered in a way as a big service design task? Or, I mean, the better you design it, the better quality of whatever outcome you get. So I mean that you talk about it as a something, but it is also how well it is designed. So let's say every year you change something, and it also changes the perception of this event.
Yeah, definitely. We could do next year. We could do a meta design study of designing a design study, and we can sort of see. It's sort of it's a complex, multi-dimensional optimization to see what elements are most important and what you want to try and emphasize and major on. So yeah, to totally agree. It is a challenge in itself to design it and get it right.
Or go completely virtual with virtual reality.
Yeah, also an option.
Yeah.
Not too hard eggs anymore.
So we have another question from Marco to Mark. The shift between physical and virtual prototype has been influenced by some material restriction, or was it other constraint or participant decision? What was actually the restrictions here?
So I think I can only really answer this anecdotally based on the analysis that we've done, because I think it is basically just based on designer practice and design practices and what they wanted to do, because basically all the teams had different equipment, but they did all have physical prototyping tools and technologies available. But you see some really interesting patterns where some teams start purely virtual. They spend the first half of the challenge making virtual prototypes, then they transition to physical, and then they sort of go to the end of the challenge. Others sort of start physical and then they go virtual, and others sort of moving backwards and forwards throughout. And so this is kind of part of what we're doing of the analysis of the data sets that we have, is trying to understand what are the factors that perhaps motivate those transitions or those sort of prototyping practices that the teams are using, and then also trying to align that with prototyping outcomes. And so we've kind of, for the second challenge, which was to do with hydropower, they had to design a low-cost hydropower unit, and then they tested themselves through the challenge, but then they've posted them all back to the guys at NTNU who are running the challenge, so we can benchmark all their performance and sort of benchmark it properly. And then we're able to sort of compare the performance of the output designs with the, I suppose, prototyping strategies that they took. And one actually really interesting thing we did with that in the last challenge was we asked teams to estimate the performance of their product halfway through the challenge, how much energy they thought it would produce. And teams that had done more physical prototyping or made physical prototypes in the first 2 days were much less optimistic than those who've just been doing sketching and CAD models. And so you sort of see this sort of level of realism of what the performance of the product would actually be.
That is really cool, a really cool observation.
Yeah. Yeah. So very nice. And also we have a question from Grant McSorley here. If I understand correctly, the participants are university based. How would you think, or what are your thoughts on involving practitioner engineers and designers? How would that affect?
It would be great to have practicing engineers and designers involved. I suppose one of the challenges with running an event like this is it takes 4 days. So there's quite a lot of time people have to give up to it. And it is, I suppose, difficult to get an engineering company to give up designers' time in such a large quantity to do something like this. We did have, for the last challenge, there was a company who said they would commit engineers to participate, but then it didn't really materialize. So I think a lot of I suppose some of the challenge of, I suppose going back to Aleksandra's question about the kind of the challenge of designing this design study is actually getting people pinned down to doing it, because you contact lots of people and people say, oh, we'd really love to participate, we'd love to take part, and then you don't really hear anything back, and then it gets nearer and nearer the time, and some universities put through teams, others don't put through teams, so it's kind of, until you're sort of actually at the point of running the event, you don't actually know who's going to turn up and participate.
So they are basically what you say, they are welcome, but please show up then. So it's
entirely welcome. Yeah, entirely welcome. I suppose it's a time constraint, and I suppose it's trying to spin out and allow industry to understand, I suppose, what the benefits are of being part of this kind of event. And actually kind of you can almost consider it an element of CPD to sort of put their design and prototyping practices under a lens. Yeah. And so you see how do they use prototypes, what are their strategies, and how can sort of interactions between industrial and university designers influence each other.
Yeah, so it could be really interesting to see also the differences here, because you are actually inviting people here to see and view, and I think that was really nice with the paper, to view the hackathon as a design research setting. So we need to go to the next paper here, paper 4, and we have one question from James. It felt that this was an approach taken by the designer rather than a research tool to study design. Could you please clarify? Thank you. I think he refers to the objectomy. Marco, please comment.
Yeah, I think I already answered to that. I know from James.
Yeah, you talked about your dividing of your paper there, exactly, and that it was from the
but
practice.
I see there is.
And can you tell me more about the emotional aspect of your method? I believe you mentioned it as something that distinguishes it from the others.
Yeah, basically because when we, according to the philosophy of Chris Bengal, when we design a car, we try to not to create a nice surface and so on, but we try to create a sort of character, I would say a soul of the object that try to be expressed through the shape. So emotional is because in order to enter in the right mindset with this method, you have to put yourself in the shoes of the object. And so not only looking from a pure functionalism, I mean something like, okay, the object has to do this and this and this, but just say, okay, if I am an object, basically, and I am able to do some interaction with other objects, imagining your IoT, smart home, or something like that, how do you act, and what are the questions that I asking to the other object?
Okay, so if you have a comment there, or you happy there, Aleksandra? Yeah. And do we have another questions about the 4 in the chat? I can't find, but I have actually one, Marco. Because when I read your paper, I was I had a thought about you have been reading Bruno Latour or Wanda Orlikovsky and the material of technology, etc. But I couldn't find those in your references. I couldn't find you in your paper. And I was wondering, have you read the book Aramis or The Love of Technology?
Actually not.
No, and I suspected that, and I just want to recommend you to do that, because when I read that, it was kind of a really a very new experience. And when you describe the objectomy as a tool or as a way and method, it really reminds me about what Bruno Latour and also the social materialists are dealing with. So I think you will appreciate the book. It's actually a research study. But also looking into that theory, because I think it could really help you if you would like to develop the objectomy as in more researcher and understand it as a construct, so to speak.
Sure.
That's
to be fair, there is also a book that I cannot put there because it was not like academic literature, but it is like The Secret Life of Building. That is more an architectural book, but it has something I would say in common, but something like inspiration for this paper also.
Very interesting. No, but I think, and also not the least, if you listen to Danica before, I mean, we are dealing with robots and we are dealing with technologies that are becoming more and more, so to speak, intelligent, or at least having other types of features that maybe it's necessary to think about the objects as more of an agent, as you suggest in your paper here. Thank you. Very nice. So let's go to paper 5. And we had a question, I'm pretty sure, here in the chat regarding, do you, the first presenter 5 here made me wonder, is commercialization success impacted by culture factors?
Yes, so this is a super relevant question, and in some ways the projects that you saw presented in the paper, they felt a bit like a social science case study into the way that academic scientists sort of view what they do. And one thing that came out was that quite often these scientists, they don't have a great desire to be the person leading the commercialization. They often just think, you know, that's something for somebody else to do. And so I guess and this kind of connects to Aleksandra's question about the quality of the designer. In that I think one of the big things that a designer or an engineer can offer within these collaborations is having that desire for the commercial success, and where the scientists maybe don't have that drive, that the designers and the engineers provide a lot of that. And I think that is a big factor in the potential commercialization success with such technologies.
Thank you. Any comment there? Yeah. Sorry.
I was going to say, I think that there's another question from James talking
exactly. I was about the risks. Yeah,
and I think with respect to that, and I think one of the really important findings in David's testing of this framework that he developed was the importance of the very front end stages. So this is the kind of the market research and so on. I think in some respects, it's obvious that if you get an engineer and a designer to help develop a demonstrator, it will function better. But where the stages prior to that help, I think, in at least tipping potential investors into investing in the technology, is by showing a kind of easily contextualized demonstrator. So what I mean by that is a demonstrator which is connected to a sort of a market opportunity or a market product. So for us, I think, in testing that framework, it really emphasized those early stages in a typical product design and development process. The later ones, of course, are important, but I think they're more obvious.
Great, thank you. Sorry?
Oh, I just said no problem.
Yeah. Okay. And we have from Grant as well. I think you mentioned that all of the projects on display had the same budget. Did this include the designer's time, or is that an additional resource in your study?
That's, let me think. That's maybe a question better aimed at David. I think budget was primarily about the material resources to kind of create something. And I think what David's talking about in terms of budget and material resources is the ability to produce something that looks more or less finished or like resolved or polished. The designer's time in the two cases where the framework was implemented, that was not factored in as a budgetary constraint.
Okay, thank you for clarifying. Thank you. We have only 2 minutes left, and I just wanted to make some kind of connection between you and have your final reflections on that, because when I took part of your papers and presentation, what struck me was that you in different ways are focusing on the design outcomes, the prototypes, demonstrators, etc., and both as a mean then to communicate complexity for different stakeholders, in the market, etc., but also for the designer and the researcher themselves, right? By focusing on the design outcomes, you as a designer, a developer, a researcher can actually learn about both the design itself, about the phenomenon, or also being supported, as you know, in terms of creativity or facilitating the process. So you all have some kind of focus around these objects and how they can support both in more traditional way communicating externally, but also internally. Would you please comment or reflect if you get a reflection on that, and how that actually also is maybe connected to the new technologies that we are dealing with in all our objects more and more?
I could jump in with something. I think if I've understood the point you wanted to make. I suppose with the idea challenge, we were interested in prototyping practices, so understanding what the purposes of the different prototypes, the purposes of the prototypes were. So yeah, I would say that our paper is very much, as you sort of described as a linking comment, and trying to understand basically how do designers use prototypes to design well, what are the purposes of them, and then how can you prescribe methods that would allow non-experienced users to then design better through those sorts of learnings. So yeah, I think it was aligned to what you said.
Yeah. And also, I just realized that I got a bit involved here. So the time is actually flying. So I have to leave you with that reflection about what connects your different papers here. But I think it was really interesting to take part of them. And I really enjoyed both reading and taking part of your presentation. So very much thank you to all the presenters, and also for the audience who put up all the good questions here so we could have a nice discussion. Thank you all. And Marco, I will just type here my
Thank you.
Thank you. Bye.
Thanks, everyone.
Thank you.
Thanks, everyone.
Thank you. Bye.
Bye-bye.